All right, this will be the last video actually for the semester. So I think I hear a hurrah go up from across the state. So wanted to look at images and doing some simple animation, really some advanced graphics. So associated with every graphics object, the figure window, the axis in the figure window, each axis in a subplot, the different lines that you may plot, the different matrices that may be plotted in an image plot, is associated with each of those graphics objects is what's known as a figure handle. And you can manipulate that handle to get very fine grained control over what the graph looks like. Okay, so we've never actually asked for a return value back from plot, but plot would return a handle to the line that's plotted. The GCA function, which is get current axis, means get the handle of the current axis. And by manipulating this handle, and I'll show you how to do that, you can change things about the axis. The tick marks, what's actually displayed on the ticks, the font size, and then also there's something for the figure window. GCF is get the handle for the current figure window. Again, there's lots of different things that you can play around with here. You can see all the properties associated with a particular handle by using the get function, or you can get one of the particular properties by passing the name of the property, and I'll show you what that means. And then you can change the properties using the set function. So I've kind of coded these into, let's take a look at the stuff that was on this slide. So here we're just going to plot a random line with 10 points, and then I get the line handle, and then also the axis handle and the figure handle. And then I change some of the properties in the axis. And in particular here, if you'll look, I change the font name, so to a different type of font, and then change the font size also. And then I change the line width and the marker style by directly manipulating the handle. And then finally, you can even change the data that appears in the plot. So let me run this. Notice also I've got some pause statements in here. A pause in a script will actually pause until the user presses enter. And so before each pause, I've got a little display statement, reminding the user who's running the script that they need to press enter. You can actually pass a numeric argument to pause, and it'll pause for that many seconds, and then it doesn't require the user to enter. But so I'm going to do this plot, and then it'll pause. After the pause, we'll see a change in the font style. It'll change from, I forget what the default is, Times New Roman perhaps. It'll change to Arial and then change the font size. And then there'll be another pause, and we come back and change the line width, and we'll see markers. And then finally, this will change the line. Okay, so let me come back up here to the command window. Let me bring up the plot. Okay, so here's the plot. Here's the plot of the original line. And I think after the first pause, if you recall, it's going to change the font that's used on the axes, and then also the font size. So let's see the font. The font actually changed. The size got bigger. The next set of statements, we're actually going to add a marker and then actually change the line width, so you'll see the line get a little thicker, and then markers, and the third one, I'm actually changing the contents of the line by directly changing one of the properties. Okay, so it completely changes the line. So if I do get L, okay, this will get all the properties in the current line. Okay, there's lots of things to choose from here. Here's the color. This is the current color of the line. If I wanted to change that, I could do set L, and then the property name has to be a string. This particular name, the color is actually an RGB pair. If I want to change it to red, it would be 1 red, 0 blue, 0 green, 0 green, 0 blue. Okay, and then that changes the line color to red. I can even, what I did in the script was actually change the Y data. I could do that again to get yet another different line by not replotting or using hold, but actually just changing the values. And what we used there was just a random vector of 10 points. It needs to be the same size. So this will create a new line without actually changing the axes or anything else, but just changing the data. Similarly, I could change the X data, the marker size that's used. There's a visibility option here. I can even, if I set that, now that's a string option. If I set that just to off, the line is not displayed. Now it's still there. It's part of the graphics window. The Y data is still there. It's just no longer displayed. Actually, so get L will display show the current values of all of the properties associated with the line. Set L will just list all the properties that I can change, but not show their current values. And it will also show the different options that are available for visibility. Will take either off or on. It shows the current state is on. And similarly, we also had, for the axis, for example, set A will display all the different things that I can change on the axis. If I want to, and part of this is the ticks. So if I get A and I get the current property of the X tick, okay, and I could assign this into an array if I wanted. Okay, similarly, I could change this 0. It's now showing a tick every space by 2. But if I actually change that so that the tick marks are actually spaced by 1, and I could do the same actually, with the Y data and the Y ticks. Here they go from 0 to 1 in steps of 0.2. But if I wanted to change that to 0.1 steps, okay. Let's see what else is in here that I can change. I can set the X grid. It takes it's currently off, but if I turn that on, I'll see grid lines at the X ticks, and similarly Y. I can set grid lines on the Y ticks. If I look at the figure handle, let's see. I'm not sure that there's let's actually just see what happens when I set the figure handle visibility to off. Now, before I made the line disappear, this completely gets rid of the graphics window. Okay, but it's still there. Okay, but I can actually remove the window just by turning the visibility on and off. So that there's a lot of features you can change with regard to graphs and axes by looking at the different handles. Let me get actually what was I can even change the labels that are associated with the tick marks. If I want to do that, I can change them actually to strings. These are actually stored in cell arrays, which is one of the things we didn't talk about, one of the advanced data structures. But if you read up on cell arrays, you could actually change the tick labels from numbers. Okay, so the complete color map is stored in here as well. I could change that to another array, or I normally change that with the color map. Let's see what happens when I just make the axis handle turn its visibility off. So that just gets rid of the axis, and all the grid lines associated with it and the tick marks and things like that, but still keeps the line plot. So lots of fun stuff that you can have here. Again, in some of the animations we'll look at, it's a lot easier just to change the data instead of replotting every time. So let's look at an example of that. You can read and write images within Octave and MATLAB. We'll play around with this a little bit. We've looked at this a little bit in the past. You can even write out animated GIFs if you want to. I'm not going to get into the GIF discussion. You can save animations as movies. Again, I'm not going to have you do this, but let's look at making animations. So here, this is just showing a random with a single argument. This is a 200 by 200 element matrix. It's going to show it 30 times and then pausing half a second in between each time. So if you take a look at that script, here it is. Okay, here we just call image scale every time and reset the color map and pause for 0.2 of a second. If image SC and color map actually ran instantaneously, then the only command in this loop is the pause of 0.2. So this thing should run in 6 seconds. 0.2 times 30. You'll see that it actually takes much longer to run because it takes a while for image SC to actually execute as it does for the color map command. So I don't know, it may take 12, 15, 20 seconds for this loop to actually run. A much faster way to do this is actually, just create the color map for the figure, call image SC to do this once, and then I just replace the C data associated with, I get a handle back. So this will be a handle for the image object in the figure. And then I just change that data array directly within the figure object, and then now pause for 0.2 of a second. So this second loop runs in approximately 6 seconds. I think it takes a little longer. So let's actually run this. Okay, so this will see, and this is running that first loop where I'm just displaying 30 random images, pausing for 0.2. I'm seeing some sort of what looks like an animation here. Of course, you could do this with regular plots, just changing the Y data like we did before. So that makes kind of an interesting plot. Now here's the second loop where I just changed the data in the image handle directly. And this one will let me select the window. Okay, now I'll press enter. This runs much faster. So instead of recreating the plot every time, I just change the data. So I get a much better looking animation here. You can do this with lines and produce or 3D mesh plots and get some pretty interesting animations using MATLAB and Octave. That is all I am going to cover, and this concludes the lectures for the semester. Yay!